In this video, we're going to walk through all the column operations we could do in a Pandas data frame. First, I would launch a Jupyter Lab notebook. I would create a Python 3 IPYNB file and rename the file. Next, I would import all the libraries and read the CSV data. The CSV data is National Longitudinal Survey data. This is a survey data which have information on multiple points in the labor market. There are many columns in this data, so I'm using this data for my analysis. I'm checking the index of the data frame. I'm checking the information or overview of the data frame by using df.info. Now there are 88 columns in the data frame. We have person ID, gender, birth month, birth year, number of weeks worked, and so on. The memory usage is 6.1 MB, and the data types are int, float, and objects. Now I want to set the person ID column as the index. So by using set index, we could set the person ID column as index. Now if we check the index by using df.index, you would see the index is person ID. The next thing is I want to pick all the columns which have object as the data type and convert them into category. Category is nothing but a string type of a data. By converting from object to category, we'll save a lot of space. Right now we have a memory usage of 6.1 MB. Let's see how much we could reduce by changing this object to category type. For that, I'm using a for loop here. For call in df.select dtypes of object.columns, this select all the columns which have object as the data type, and it changes the data type to category. Now if we check the info, you could see all the objects are converted to category. Now if you look at the memory usage, we have 2.7 MB compared to 6.1 MB when we have object as the data type. Next, we'll try to select a column using bracket convention. We have all these columns in the data frame. I want to select the gender column by using bracket notation. So gender data is df of gender. So this is the column name, close the bracket. This extracts the gender column from the data frame and is assigned to gender data variable. Now if you look at the type of the gender data, we could see is a Pandas series. Pandas series is a one-dimensional labeled array in Python. This is a one-dimensional data. It's not a data frame, it's a series. If you want this gender data as a data frame, then we use two brackets instead of one brackets. For example, df, and within brackets we have to list the column name inside another bracket and then close the final bracket. This creates the gender data as a data frame instead of a Pandas series. So when we look at type of this data frame, we could see it is a Pandas data frame compared to Pandas series. Now we could also select the columns by using loc selector. So I'm calling the gender data with loc, and the syntax is df.loc in square brackets. The first column indicates it selects all the rows, comma, and in square brackets we gave the column name gender. That means it selects all the rows in gender column and it creates a data frame with that data. Now if you look at type of gender data with loc, it is a Pandas data frame. Now we could also select columns by using iloc instead of loc. The difference between iloc and loc is in loc we are giving the name of the column here, whereas in iloc we can just give the index number of the column. For example, gender column is the 0 index in the data frame. Birth month is index 1, birth year is index 2, highest grade completed is index 3, and so on. Since I want gender column, I will use the index 0 to pick the gender column. If we look at the info of this data frame, we could see it has the column gender with the type and usage. Next, we'll look at how to select multiple columns from the data frame using loc. So I'm creating this data frame df gender, marital status, and highest grade completed with loc. This is the name of the data frame. df.loc in brackets, first column, comma, the names of the columns. If you look at the info of this data frame, we got all the columns and the values in the data frame. Next, we'll select multiple columns based on a list of columns. I want to pick some of these columns, so I will create a list of all the required columns and then pass it into the df to get my required data frame. So the first list I created is required columns. I want all these columns. My df required is the required data frame is df, open the bracket and pass this list into this data frame. So my df required data frame now has all these columns. If we check at the info, we got all these new columns in my new data frame. We could also select columns by using a filter. So let's look at columns once. These are all my columns. Now I want to pick all the columns which have weeks worked in the column name. Data frame work df is df.filter like equal to weeks worked. Now my work df data frame has only the columns which have weeks worked in the column name. Let's try to select columns based on data type. I want to select all the columns which are of categorical data. First, let's look at the different data types we have. So these are the different data types. We have float, category, and integer. Now I want to select the columns which are of category data type. df.select dtypes include category. If you check the info of the df category data frame, we get all the columns which are only of category dtype. Now select all numeric columns. df numeric is df.select dtypes include is number. If we check the info, we could see all the columns with integer or float as the data type. We could also select columns based on a regex pattern or regular expression pattern. What is a regular expression? A regular expression is a sequence of characters that specifies a match pattern in text. Here I'm filtering the columns which have a regular expression of income in the name of the columns. So when we check the info of this data frame, we get two columns which have income in their column names. So these are the different column operations we could do on Pandas Dataframe. That's all for this video. Thank you for watching.